The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, what I want to do first of all is just do a quick review of what we covered yesterday. Let's see here. Okay, so let's take a look at, can you see problem number 19 from WebAssign on the left side of your screen? Just somebody give me a,
yeah.
Okay, thank you. Just wanted to make sure I clicked the right buttons. It says determine the vertex and the axis of symmetry of the graph of the function, and then graph it. Okay, so we've got, come on, let's see if it'll work now. There we go. We've got f of x equals 1/2 times the quantity x plus 1 squared minus 3. All right, a equals 1/2, which means this thing opens upwards, okay? And it's going to open wider than, like if this is y equals x squared, it's going to open wider as opposed to narrower because it's between 0 and 1, okay? If we think in terms of y equals a times x minus h squared plus k, this could be written as 1/2 times x minus -1 squared plus -3. So in other words, writing it in this form. So h is -1 and k is -3. Any questions about that? All right, so the vertex is at hk, so it's at -1, -3. -1, comma, space, -3. And the axis of symmetry is at x equals h, so x equals -1. And again, you've got to write it as an equation, x equals -1, okay? Now, we're going to graph this thing. And as I mentioned yesterday, to graph it, we need 2 points. We need the vertex, which is -1, -3, and then we need one other point. Okay, I'm just going to let x equal 0 and let's see what we get. So f of 0 is 1/2 times 0 plus 1 squared minus 3, which is 1/2 times 0 plus 1 is 1. Order of operations, 1 squared is 1. 1 times 1/2 is 1/2. So we've got 1/2 minus 3. So 1/2 minus what? 6/2, which would be -5/2. Okay. So over here, click on this till it turns blue. -1, -3. 0, -5/2, which is -2.5. Now, notice it didn't go where I wanted it to, so I'm gonna let's see, move this over a little bit so I can. So I've got my -1, -3. This is going to be what? -5/2. And let's see if that's correct. All right. Now, today, we're going to look at a different way of graphing parabolas from a different form of a quadratic equation, as well as finding x and y intercepts and maximums and minimums. So let's start out with a second degree equation that's in a different form. It's not in the form y equals a times x minus h squared plus k. It's in this form, y equals ax squared plus bx plus c, okay? When it's in that form, the axis of symmetry is at x equals negative b over 2a. All right. Now, our actual problem, f of x equals x squared plus 4x plus 9. A is 1, B is 4, and C is 9. So negative b over 2a would be negative 4 over 2 times 1, which is negative 4 over 2, or negative 2. So the axis of symmetry is at x equals negative 2. So x equals negative 2. All right. Now, the vertex, the vertex is at negative b over 2a. In other words, that same x value, and then f of negative b over 2a. In other words, we find the axis of symmetry, x value. Then we take that, which in this case was what, negative 2, and we plug it into the function. So we find f of that. Okay, so it's going to be negative 2 comma f of negative 2. What is f of negative 2? That's negative 2, the quantity squared, plus 4 times negative 2 plus 9, which is 4 minus 8 plus 9, which is what? 5. So the vertex is at negative 2, 5. Any questions? Now, the a value in this form is the same as the a value in the other form. In this case, a is a positive 1, so it's going to open upwards. Any questions about this example? All right, let's do another one. We have, let's see here. Yeah, we'll do 21. Okay, so we've got f of x equals negative x squared plus 6x minus 12. So a is negative 1, b is 6, and c is negative 12. So the axis of symmetry is at x equals negative b over 2a, which is negative 6, over 2 times negative 1, which is negative 6 over negative 2, which is 3. So the axis of symmetry is at x equals 3. Again, the equation x equals 3. The vertex is at 3 comma f of 3. Now notice this negative sign is not part of the square. So I take 3 and square it and then apply the negative. Let's see, what is that? Negative 3, negative 21 plus 8, negative 3. So vertex is at 3 comma space negative 3. A is negative 1, so it opens downwards. Any questions about that example? Okay, so this one says find the vertex, find the vertex. Here we go. Here's one where they want us to find the x and the y-intercepts. Let's go back to linear functions. Let's say we've got, or just a linear equation, 2x plus 3y equals 12. To find the x-intercept, we set y equal to 0. To find the y-intercept, we set x equal to 0, right? Any questions about that back in with linear stuff? All right, now let's take a look at a quadratic function or second degree of function. F of x equals x squared minus 4x minus 45. That's the same thing as y equals x squared minus 4x minus 45. To find the x-intercept or intercepts, set y equal to 0. So we have this. Oh, how do you solve a second degree equation set equal to 0? Well, back in chapter 6, we learned how to do it factoring, and we could try and see if it factors, and I think it does, but we could also use the quadratic formula. So let's see what happens when we use the quadratic formula, okay? A is 1, B is -4, and C is -45. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 4 plus or minus the square root of 16 plus, let's see, we've got minus 4 times 1, which would be -4, times -45, which would be a positive 180, all over 2. X equals 4 plus or minus the square root of 196, all over 2. X equals 4 plus or minus, let's see here, the square root of 196 is 14, all over 2. So x equals 4 plus 14 over 2, which is 18 over 2, which is 9. X equals 4 minus 14 over 2, which is -10 over 2, which is -5. So we've got those two x-intercepts, right? Okay, think about it, a parabola. Well, let's go back. Let's see here. What am I doing? I'm doing number 24, but let's go back here. Doesn't this thing cut through the x-axis twice and through the y-axis once? So it could have two x-intercepts. Okay, now. Right. Okay, so to find x-intercepts, you set y equal to 0 and then use the quadratic formula. Oh, so that means if we take a second degree equation or a second degree function and we set it equal to 0, let y equal 0, use the quadratic formula or factoring and come up with the solutions, those solutions are the x-intercepts. Now, it says smaller x value, larger x value. Don't ignore the instructions. I've had people put the right answers in the wrong places and they both get marked wrong. Also, it's an ordered pair. It's not a single value. That's another thing people miss. So this is going to be -5, 0, okay, and then 9, 0. All right. Now, how do you find the y-intercept? Set x equal to 0. Well, if x equals 0, what is f of 0 going to be? Well, that's going to be 0, and that's going to be 0. And what's going to be left? C. Because when it's in this form, standard forms, descending powers, when x is 0, that's going to be 0, that's going to be 0. That C, that constant, is going to be the y-intercept. So 0, space, -45. Any questions about that example? All right. Let's take a look at, let's see, let's find one. Let's take this, let's do this one here. Okay. So we've got f of x equals x squared plus 2x. So for this problem, a is 1, b is 2, and c is 0, isn't it? Okay. So now, they don't ask for the axis of symmetry, but basically we find the x value of the vertex by finding the axis of symmetry. So I'm going to go ahead and find it. The axis of symmetry is at x equals negative b over 2a, which is negative 2 over 2 times 1, which is negative 1. So the axis of symmetry is at x equals negative 1. Okay, so then the vertex is at negative 1 comma f of negative 1. Well, f of negative 1 is negative 1 the quantity squared plus 2 times negative 1, 1 minus 2, negative 1. So the vertex is at negative 1, negative 1. Is that right? I think so. Okay. So there's our first piece of information. The vertex is at negative 1 comma negative 1. All right. Now, to find x-intercepts, we're going to set y equal to 0. Oops. If I push too hard, it goes to the next page. So we get that. I can solve that by either factoring of the quadratic formula. I'm going to use the quadratic formula. I already have my a, b, and c right there. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X is negative 2 plus or minus the square root of 4. Minus 4 times 1 times 0 is 0, so it's just minus square root of 4, excuse me, plus or minus the square root of 4, all over 2. X is negative 2 plus or minus 2 over 2. So x is negative 2 plus 2 over 2, which is 0 over 2, which is 0. X is negative 2 minus 2 over 2, which is negative 4 over 2, or negative 2. So our x-intercepts are at 0, 0, and negative 2, 0. Okay. Oh, I didn't do this correctly, did I? In fact, it looks like I used a period instead of a comma. So this should be 0, 0, and this should be what? Negative 2, 0. Okay. Also, this already has the parentheses. I've had students add the parentheses inside the box, and then that confuses WebAssign. So pay attention to the stuff they're saying here. Don't just plug the numbers in and walk away. All right. What's the y-intercept? C. All right. Because when x is 0, you get, so the y-intercept is at 0, 0. Oh, there's an x-intercept and a y-intercept at the same place. This thing goes through the origin, doesn't it? All right, now plot several points and complete the graph. Just like before, we want to plot 2 points, the first point of which has to be the vertex. So -1, -1. The second point, I could use any of these. I could use 0, 0 or -2, 0. I'll go ahead and use 0, 0. I'll come over here and confirm, yes, it's where I wanted it to be. Okay. And there you have it. Okay. Any questions about that example? All righty. Let's see here. Let's do this one. All right, determine the coordinates of the vertex of the graph of the function using the vertex formula, then determine the x and y-intercepts of the graph. All right. In the vertex formula, that's x equals negative b over 2a, and then y is f of negative b over 2a. All right, so we've got f of x equals negative 6x squared minus 12x minus 20. A is negative 6, b is negative 12, and c is negative 20. X equals negative b over 2a is negative times negative 12 over 2 times negative 6, which is 12 over negative 12, which is negative 1. Let's see. Negative times negative 12 over 2 times negative 6, 12 over negative 12. Okay, so the vertex is at negative 1 comma f of negative 1. Which is negative 6 times 1 plus 12 minus 20, negative 6 plus 12 minus 20, which is what? Negative 14. Negative 6 plus 12 is 6, 20 minus, yeah, negative 14, so negative 14. Okay? So the vertex is at negative 1 comma space negative 14. Any questions there? All right. To find the x-intercepts, we'll set y equal to 0. Okay. So what have we got here? We've got, oh, right there, we've already got our a, b, and c, right? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 12 plus or minus the square root of negative 12 times negative 12 is positive 144. And then we've got minus 4 times negative 6, which would be 24 times negative 20. Oh. Hang on. Just a second here. I'm going to. Okay. So I was panicking because, oops, I was going to get a negative value inside of there. But then I looked over here at the instructions, and one of the options, it says if an answer does not exist, enter D in E. Well, let's keep going. Let's hope I'm right. So x equals 12 plus or minus the square root of, let's see here, negative 336 over negative 12. Well, the square root of a negative number is not real. So there are no x-intercepts if I've done this correctly. So let's find out. So I've got D in E. Okay. How about the y-intercept? Oh, when x is 0, we get that. So that's going to be at 0 comma space negative 20. Okay, all that's left is to graph this thing. I need to start with the vertex. Oh, look at my graph. The squares are in increments of 3. So that's going to be a little tricky to graph, isn't it? Well, not necessarily. Let's find out here. So here, Vertex is at -1, -14. So it's right about there. And then the Y-intercept is at 0, -20. So right about there. Let's see here. This isn't quite where it's supposed to be. I'll make that. And that isn't quite where it's supposed to be. So we'll make it like that. Well, here comes the moment of truth. Let's see what happens. By golly, I guess I better go out and buy a lotto ticket, huh? All right, now, notice that this parabola, it does cut through the y-axis, okay, or y-intercept, but it does not cut through the x-axis. That's why there's no x-intercepts. If we have a parabola that has the vertex below the x-axis and it opens downward, there's no x-intercepts. If we have a parabola that has the vertex above the x-axis and it opens upwards, there's no x-intercepts, okay? How do we know there's no x-intercepts? Because back over here, let's see, where the stuff underneath the radicand, that thing's called the discriminant, the b squared minus 4ac. If that's negative, you're not going to have real x-intercepts, okay? Any questions about that? Also, I want to point this out. This graph opens downwards. So the vertex is at the maximum. The maximum value of this parabola would be the y value of the vertex, which is -14, okay? It occurs, the when is at -1. The what it is -14. Let's go back here to this one. This has a minimum. When is it at its minimum? When x is -1. What is its minimum? The y value, which also happens to be -1. Minimum and maximum values are going to be important in a little bit when we get to some application problems. Let's see here. Speaking of application problems, let's go ahead and let's look at some. All right. Any questions before we go on? Okay, so what I'm going to do now is I'm going to go back to just our regular screen, and let's get rid of that, and we'll stop sharing and over here. Okay. So now can you see my whiteboard?
Yeah.
Thank you. All right, we're going to look at some application problems. This first one says operating costs. The cost C, so capital C in dollars, of operating a certain concrete cutting machine is related to the number of minutes in the machine is run by the function C of n equals 2.2 n squared minus 66n plus 655. Okay, so n is the number of minutes run, and C is the cost of doing that. Okay. Notice what we've got here. We have a quadratic function or second degree function. Also notice that A is 2.2. A is positive, which means this thing is going to open upwards, right? If A is positive, it opens up. If A is negative, it opens down. Okay. The question we want to answer is this: for what number of minutes, so that would be n, is the cost of running the machine a minimum? All right, now, again, the graph of this thing is going to be a parabola opening upwards. So the vertex, which is going to be at the bottom of the parabola, which is going to be n, and then C of n, right? The n value, the input, the n value would be the number of minutes for the cost of running the machine. And then it says, what is the minimum cost? So basically, it's asking us for the two numbers that are the vertex. Okay, so let's find the vertex of this parabola. A is 2.2, B is -66, and C is 655. Now this C is not the same as that C, right? So don't get those confused. So X equals -b over 2a. Technically, it's n equals -b over 2a, right? So we've got negative times -66 over 2 times 2.2, which is 66 over 4.4, which is 66 divided by 4.4, 15. Okay. So n equals 15. That's the number of minutes that produces the minimum cost. How do we find the minimum cost? We find C of 15, which is 2.2 times 15 squared minus 66 times 15 plus 655. And let's see here, doing the calculations, 2.2, whoops, 2.2 times 15 squared minus 66 times 15 plus 655, and I'm coming up with 160. So basically the vertex is that. N equals 15 minutes, and C equals, or C of 15, I guess we could say. C of 15 equals $160. So having done all the calculations, let me read it again. The cost C in dollars of operating a concrete cutting machine is related to the number of minutes N that the machine is run by the function and then this given function there. For what number of minutes, so that's N, is the cost of running the machine a minimum, and what is the minimum cost? That's that. And again, so this relates to the fact that we've got a parabola that opens upward, so the vertex is a minimum. If we had a parabola, if we produced one opening downward and it asked for a minimum, we'd be in trouble. Okay, so this has got to be consistent. All right, any questions about this particular example? Okay, go on to another one. This says, let's see, projectiles. A ball is thrown straight upward from the top of a building with an initial velocity of 32 feet per second. The equation S equals -16t squared plus 32t plus 48 gives the height S of the ball in feet t seconds after it is thrown. Find the maximum height reached by the ball and the time it takes for the ball to hit the ground. Okay, so what have we got? We've got this building and a ball is thrown straight upward and then eventually it's going to hit the ground. Okay, and T is this axis, which is time in seconds. And then this axis would be S, which is distance above ground. Okay. So a ball is thrown straight upward from the top of the building with an initial velocity of 32 feet per second. The equation S equals -16t squared plus 32t plus 48 gives the height S of the ball in feet t seconds after it is thrown. So S is in feet. Notice, let's take a look at this thing. This is a second degree or quadratic equation. in that descending powers form. A is -16, which means the graph of this thing is going to open downwards, which is good because look at our path that I've drawn of the ball. It's a parabola opening downwards, right? Okay, now it says, where did it go here? If the show, no, wrong one. Find the maximum height reached by the ball. So that would be, let's see here. That would be the S value of the vertex, right? T is the time after it's been launched, and S is its height at some given time. So the maximum height would be the S, or the output value of the vertex. Okay, so I've got to find the vertex. Okay, so A is -16, B is 32, C is 48, X equals -B over 2A. Technically, it's T equals -B over 2A. So -32 over 2 times -16, which is -32 over -32, which is 1. So actually, we'd say T equals 1. Okay, but then I need to find, that's the, so after 1 second, it reaches its maximum height, but they want to know the maximum height. So I've got to put 1 in for T. So we get what? -16 plus 32 minus 48. Something's wrong there, isn't it?
Is it plus 48?
It is. I was just spotting it. Why did I know it was wrong? Because I was going to get a negative value, and it's like, okay, so after 1 second, the ball is underground. Something's wrong there. Usually if something doesn't look right, it isn't. Okay. So let's see, I've got what, 64 there? 16, yeah, 64. So the vertex is at 1, 64. 1 stands for the time in seconds, 64 stands for the height in feet. The question said, find the maximum height, okay? So maximum height is 64 feet. It did not ask for the time during which it reaches the maximum height. Sometimes it might. What it asked for, it's after that it says, and the time it takes for the ball to hit the ground. So we don't want to know the time here. We want to know the time here. Oh, isn't that the X, or in this case, the T-intercept? Okay. So when is the height 0? So let's see if we can reach this in here. So the height 0. So we've got this. Okay, we've already got our A, B, and C. So T equals -B plus or minus the square root of B squared. Let's see, minus 4AC all over 2A. I think I should go to the next page. I'm running out of room there. -B plus or minus the square root of B squared minus 4AC. So that gives us T equals -32 plus or minus, let's see what 32 squared is. 32 squared is 1024. And then minus 4, so -4 times -16, which is 64 times 48 is 3072, all over -16 or -32. Okay, because 2 times -16. All right, so proceeding. 3072 plus 1024 is 4096 all over negative 32. Now the magic question, is that a perfect square? Yes, it is. Sweet. My daughter says I'm too old to use the word sweet, but she's not here. Okay, so t equals negative 32 plus 64 over negative 32, which would be 32 over negative 32 or negative 1. So t equals negative 1, or t equals negative 32 minus 64 over negative 32, which is negative 96 over negative 32, which is 3. So we're coming up with t equals negative 1 and t equals 3. Well, let's go back here and look at the problem. Regardless of what science fiction will tell you, our understanding of the world, there isn't negative time. So the answer, the time, has got to be the 3 seconds. But what does that negative 1 correspond to? Well, if we graph this parabola on down here, this would be the t equals negative 1 value. But keep in mind, the ball didn't start here underneath the building, it started here on top. Okay, so that would be like the, I don't know, the S-intercept, so to speak. Okay, so 64 feet high, it hits the ground in 3 seconds. Questions on that one? All right, one more. Let's see here. We've got this situation. We've got a stream, and a farmer decides, a rancher decides to build a fence of which there are 1,000 feet, and he's going to build it 3 sides of a rectangle. Okay, and then he's going to put the cows in here. Here's the cows, lovely cows. Yes. Anyway, first of all, I want to say the farmer's nuts because, or the rancher, the stream would not hold them in. The cows would wander out there, and anyway, but that's just a personal note, having lived on a cattle ranch. Okay, now we've got 1,000 feet of fence, and we want to build 3 sides of a rectangle, but the cows are going to be grazing on grass in this area. So we want to maximize the area of that rectangle. Okay, now consider this. Let's say this represents the 1,000 feet. Okay, and I'm going to fold this piece and this piece. So I've got my 3-sided fence. I don't know what any of the dimensions are, but I do know that these 2 sides of the rectangle are equal. So I'm going to call both of these pieces, these little pieces at the end, I'm going to call them X. Each one is X. Okay. If the whole thing is 1,000 and I get rid of that piece and I get rid of that piece, don't I have 1,000 minus 2X left over? Everybody see that? Does anybody get it?
Yes.
All right, just making sure. So now the area is length times width. So the area, and I'm going to write it as a function, would be 1,000 minus 2x times x, which is 1,000x minus 2x squared, which, putting it in standard form, is negative 2x squared plus 1,000x. Okay. So there's the function or the equation that's relative to the area. Okay. X, the input would be what, this length here, and A of X would be the total area that the cows can graze in. Now, it says a farmer wants to fence 3 sides of a rectangular field with 1,000 feet of fencing. The other side of the rectangle will be the river. If the enclosed area is to be maximized, find the dimensions of the field. All right, take a look at this. That's a parabola that opens downwards. The leading coefficient is negative. That's a good thing because this axis is X, this axis is A of X. So what are the dimensions that will produce the maximum area? Okay. The maximum area is the Y value of the vertex, and this will be the X value of the vertex. So find the vertex. A is -2, B is 1000. All of the story problems in this section have to do with parabolas and typically asking for maximum or minimum values, which is part of the vertex. X equals -b over 2a, -1000 over 2 times -2, which is -1000 over -4, which is 250. So this is 250. This would be what? 1000 minus 2 times 250, which is 1000 minus 500, which is 500. So the dimensions would be 250 feet by 500 feet. Okay. Now, it didn't ask in this particular problem, but suppose it asked for that maximum area. Well, that would be what? A of 250, right? You'd plug that in to find the maximum value, or you could take 250 times 500 and get it that way, either way. Okay, so this is Friday. For tonight, you've got to finish up section, what, 10.4 and the chapter review. On Monday, we'll have review for the chapter 10 test. And on Tuesday, there'll be no class meeting. We'll just have you take your chapter 10 test. I will be back today at 1:15, should you have any need for me. Otherwise, I'm going to go ahead and stop the recording. Maybe.